Okay, so we're told here that in the accompanying diagram we have a trapezoid ABCD, and I would just go on to the diagram and label that. So here's A to B, to C, and to D. It's a good idea to label or get familiar with the location of the letters so you can follow what they're saying. They're saying here we have this trapezoid, and now they're going to tell you how long each segment is that they're giving to you here. So we have AB is equal to 26. You might find that here. That's the whole base, 26. BC is 10. BC is this segment up here. CD is 18, right? 18. Oh, that is the segment up here. Sorry, CD is the segment up here, and BC is right here, this vertical line. And we're told that CB is perpendicular to AB, and that's the right angle you're seeing right here. Here's CB and AB, they form a right angle. Altitude DE, so it's a line right there, DE, which crosses another line at a right angle. That's an altitude, and they're saying that DE is an altitude. They want to know what is the number of square units in the area of trapezoid ABCD. So they're asking for the area of trapezoid ABCD, and what we have to realize is that CB, right, since it crosses AB, or it's perpendicular to AB, that means they cross at a right angle, and this means that CB is equal to the height. Right? It's a vertical line. It's also equal to DE, right? So we can say CB is congruent to DE, right? They both equal 10, and that equals the height, right? So here, I'll label this, we have the height of our trapezoid, and we have the upper and lower bases, and we can find the area. And then we'll talk a little bit about why this makes sense. So what I do is 18 plus 26, add those two areas, divide by 2, and multiply by the height. Now, we don't need to actually do all these calculations because one way to think about this is to say, oh, well, 10 divided by 2 is just 5, right? So we can actually reduce the calculations we need to make, and we get 5 times 18 plus 26. Next thing I might do is add 18 and 26, right? That's 44, right? 20 and 10 is 30, 8 and 6 is 14, so 5 times 44. 5 times 40 is 200, 5 times 4 is 20, that's 220, and that's the area of our trapezoid. Now, we should understand a little bit about this formula so we can deal with tougher problems. And the idea is that if you have a trapezoid, maybe something like this right here, well, why is the area the way it is? Well, why is this formula that we're often given the formula that works? In other words, why is it that the area equals base 1 plus base 2 times height divided by 2? And that's the formula you're often given, right? Base 1, which might refer to the top piece over here, and base 2, this bottom piece, and any vertical line in the trapezoid that's at a right angle here as the height. And the formula you're often given is what I used right here for area, and that's just B1, base 1 plus base 2 times the height divided by 2, right? You can combine this in different ways. Usually you'll see it like this. So why does that make sense? Well, if we double the trapezoid, something interesting happens. If I double it and flip it so that base 1 is now here, and the longer base 2 is there, and this is meant to be an exact copy. Let's try to make it look good here. Okay. So now imagine we basically have the same trapezoid but upside down, and that means that base 1 is here and base 2 is now up here. What happens is that by doing that, we can see this new shape kind of form from these two trapezoids. We have, highlighted in red here, this parallelogram. So we can tile the trapezoids to form a parallelogram. And to find the area of a parallelogram, we still have the same height, so it's going to be height times the length of the base. But in this case, what is the length of the base? Well, that's just base 1, right, from here to here, plus base 2. So it's height times base 1 plus base 2. That's how we find the area of the parallelogram. But that's the area really of this huge parallelogram, which is two trapezoids. So if I want to know the area of one trapezoid, I then cut this in half. So I multiply by half or divide by 2. since we can think of division by 2 as multiplying by a half, we can write this in different ways. We can have h over 2 times b1 plus b2. We could have b1 plus b2 cut in half and then multiplied by h. You have a little bit of flexibility there to find the area of a trapezoid. All right, hope this helped.